This is section 4-5. This is on multiplying and dividing monomials. Key concept to start with is this product of powers. So you'll see this where it says a to the m power times a to the n power equals a to the m plus n power. So you'll see this come up. That's on page 203. And then you'll see on page 204 another key concept of quotient of powers. And that goes a to the m power over, or divided by, a to the n power equals a to the m minus n power. So in other words, whenever we multiply a number with an exponent and that same number with a different exponent, or just another exponent, you end up adding the exponents. And when we divide two numbers with the same number or letter, then the variables or the exponents get subtracted. And I'll show you what that means on these next couple examples. Let's start with example number 1. Example 1 says 7 to the third power times 7. Well, just so we're aware, 7 is really just 7 to the first power. So what the key concept is saying is this is the same as 7 to the 3 plus 1 power, which is 7 to the fourth. And that is your answer. But just so you understand where that comes from, 7 to the third power is 7 times 7 times 7. And you're also timesing by another 7. So as you can see, that gives you 7 times 7 times 7 times 7, which is 7 to the fourth. Pretty simple concept. Let's try example number 2. Example 2 says x to the fifth times x squared. So again, this is, since you're multiplying, what ends up happening is you add the exponent. So it ends up being x to the 5 plus 2 power, which is x to the 7th. But just so you are aware also, this is where it comes from. X times x times x times x times x times x times x. So obviously that gives you x to the 7th. And the next question, let's look at example 2b. Alright, and this one says negative 4n to the third power times 2n to the sixth power. So really, you don't have to have the parentheses in there. These are just multiplying. But, you know, we could break this down, and you don't have to do this. You'll see the pattern here, but this is negative 4 times n times n times n times 2 times n, 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 n. So if you notice, you can just rearrange some things. We could end up writing this right there. So it's just negative 4 times 2 is negative 8. And then if you count up all your n's that are being multiplied, that is n to the 9th power. So that's your final answer, but you know, you don't have to break it down like that. You can basically just do negative 4 times 2, which is negative 8, and then through your n to the third and n to the sixth, that's n to the 3 plus 6, mess that up there, n to the 3 plus 6 power, which is n to the 9th. So that's where that comes in. Alright, let's try another one once again. Let's go to example 3. Alright, example 3 says 5 to the 7th. This is example A. 5 to the 7th over 5 to the 4th. Since we're dividing, the shortcut pattern here is to subtract the exponent. So it gives you 5 to the 7 minus 4, which is 5 to the third. But just so we're aware also, this is another way to write this. 5 times 5 times 5 times 5 times 5 times 5 times 5. There's 7 5s over 5 times 5 times 5 times 5 times 5. I think I said 4 there. 4 5s over 7. So you can see as you start to simplify this, 4 sets of these cancel out. So what's left is 5 to the third power. And you could put that over 1 if you wanted, but it doesn't need that fraction. So that's letter A. Let's go to B. B says y to the 5th over y to the 3rd. So the shortcut is y to the 5 minus 3. Anytime we're dividing, the exponents get subtracted. So that's y to the 2nd power. And then again, you can write this as 5y's on top, 3y's on the bottom, so that leaves 2y's on top. And you'd be still over 1. That's example 3b. Let's go to example 4. Example 4 says the table compares the processing speeds of a specific type of computer in 1999 and 04. Find how many times faster the computer was in 04 than in 1999. Well, to figure out how many times faster, they're setting it up as 2004 is 10 to the 10th, and 1999 is 10 to the 9th. So anytime you divide, the exponents get subtracted. So it ends up being 10 to the 1st power, which is just 10. So this is 10 times faster. And that's your answer for example 4. Good luck.